Okay, I thought long and hard on how I was going to do this, um, and um, and I apologize for how bad the sound is. I know it's horrible. I even went and searched and found my actual soundboard. I was going to try to change and edit the sound to get it to going through the soundboard as I was recording to get a better sound. But because the microphone that I have is a regular mini plug, not a actual USB. So and I can't find the power cord to the actual soundboard. I have no idea where it's at, and it's proprietary. The only thing I could do is actually open it up and wire and solder new wires onto it, which is not a big thing at all. But at the same time, um, you know, I have to go back and find out, check the model and see what the actual input of the actual power is. Because either I'm going to have to actually create my own transformer, or create some resistors to actually go through to actually lower the voltage that's going into the device, so I don't kill it. But nonetheless, that's what I'm trying to do. Because at this point, until I find work, guys, I mean, it's whatever I have on hand. So it is what it is. I thought really long and hard about addressing, and this is what we're going to do. We're going to talk about decibel first, okay, and really show you how our numbering system actually works from the perspective of how we're going to translate that knowledge over to binary. And that's it. We're not going to talk about subnetting in this actual video. I think my last mistake, why it was always so confusing, especially when I was doing the wild cards. The wild cards are so powerful that still people in the field for decades have no idea the power of a wild card. Okay, and when I tried to explain it, I just made people more confusing, and they went back to the old way of just memorizing the steps on how to do wildcard math. And memorizing is not understanding. And I'm trying to get past that, and I have to go back and do my wildcard knowledge again to give you an understanding. And if I could actually get that point across, okay, every video, everything that I have failed in the last since 1994, since I got in IT, will be worth it, because that was something I really wanted to actually address, and I just couldn't do it. And those who are following on Facebook, you know what I'm talking about. I had to end up even deleting that post because, I was so wrong as far as I wasn't wrong on the concept. What I was wrong was the examples. And those examples were confusing people because I was writing the wrong numbers, because I was rushing. I was trying to get this stuff done. So, nonetheless, and you're gonna watch me drink coffee. What do you think this is? You're in my space. Okay, all right. Don't even get me started on the green juice either. You guys remember that? We're going back to that too once I find work. You watch. Gallons and gallons of green juice all over this damn place, and ain't nothing you're gonna do about it. So now, let's talk about decibel, our numbering system. Okay, what do we have? Okay, God, I wish I had a pen. 1, 2. Let's actually do it this way. 2, 3, 4, 5, 6, 7, 8. Oops. 9 and 0. Okay, you thought I was gonna put 10, right? No, because 10 is not a digit; it's a number. We're talking about the digits, the numbers that we have in our system. Okay, to make up all the numbers in our world. Okay, and you know what's funny? I don't know where it was from, but it was hilarious. And it probably was. It's probably Futurama, knowing them, or Rick and Morty. Either way, there was the person was talking about doing something, and they were like, you got to wait for so many years, and it's like, well, how many? Oh, I'm sorry, so many days. How many hours are in an actual day here on Earth? And they were like 24 hours. And he was like, that's it? Right? And that's exactly it. So, like, if you're watching something like Marvel, okay, and Thor's talking about, And this drives me crazy because, first of all, it's me, right? This is who I am. And if you ever get to know me, you'll be like, God damn, Kyle's a little bastard. You know, when Thor says I've been alive for 1,500 years, I'm like, well, whose years? Matter of fact, how many days are actually on Asgard? I mean, how many days, how many hours in a day does your sun ever go down? Because every time I see it, I don't think I've ever seen Asgard at night. So it's like, and I'm talking about cartoons or actually the MCU. Did I say that right? Doesn't matter. All right. So, and that was just funny because when we talk about light years, imagine taking it. If math is a universal language, how do we take our years and bring it over to somebody else in a universal fashion when their years could be actually 700 days? All right. But nonetheless, I'm digressing right now and going back to the topic. Okay. So now, all right. So, I'm counting the actual digits that we have. And we have 10 digits in our numbering system. You know what that means? Now, any idea? That means our numbering system is a 10-based system. Okay? Because we have 10 possible digits to make up all our numbers. Okay? Now, if that's the case, okay, I'm going to do some horrible drawing here. Yeah, I know. All right? If that's the case, if I take a calculator here, all right, we're going to go back to elementary school, and it's going to make sense. And where the hell is my mouse? I made that thing big and black for a reason. Where the hell is it? Yo, did I just lose my mouse? Okay, there it goes. It's resetting. Yeah, I did nothing. My mouse does that sometimes. There it goes. Okay, so now. And you know what's funny? I used to think, I knew what it was before, but my USB is a 7-port USB, and it has a power supply to it, or it's something you can plug power into. And I got power to it. And I didn't know how much power to put because it didn't say input. I mean, I don't know. I don't want to destroy my devices, so I got 6 volts going into it. I might have to have more. Because I remember before where we used to drop. I know I'm getting off topic again. I know when it used to drop before, it was because of lack of power, and that thing used to drop like every like 2 or 3 minutes while I was playing games and stuff, and that thing would drive me crazy. Nonetheless, back to elementary school. If I took 10, okay. Oh, by the way, all right, your calculator. All right, you start off with this, right? Okay, we don't want to do that. We want to go to standard. I'm sorry, standards. We want to get off of standard and go to scientific, okay? All right, and this button right here is what we're going to use. Now, this button here, the x to the second power, what's it going to do? It's going to square it, okay? 8 times 8 is 64, right? All right? However, we want to be able to put our value in there, okay? So if we go and we say 8, all right, I don't want to square it. I want to cube it. Okay, see my point? All right, we got 8 times 8, which is 64, and 8 times 64. So what is 64 times 8? 512. All right, you get my point? All right, so that's what we want to use. Now, if we take our 10-base system, we're going to go 3 places. And I say 10, which is my base, and I go to the 0 power. That gives me the value of 1. Okay, and we can move this over here. You see I got that right there, right? The value of 1, power of 0. If I do 10, okay, to the power of 2, that gives me 100. Okay? Oh, I'm sorry. I messed up. I'm sorry. 10 to the power of 1. That gives me 10. And then power of 2 gives me 100. Okay? As you can see, what are we doing here? Does this look familiar? right? 10 times 10 times 100 times 1,000. And we just add the zeros together. That's how we do that quick math, right? That's the little things we learn in elementary school. Okay? But look at here. There's also something that you have to recognize how we're doing this. And it's funny how they never teach this in school. Okay? It's not until you get into binary where this actually plays a factor. Okay? Unless, of course, I haven't been in school, God knows how long. I don't know what the hell they're teaching. All I know is they're not treating math the way I'm staying on topic. Now, okay, so remember back in the day, we had a number 1, okay, and that was the one place. But once we added a 0, that 0 now becomes what? The 10th place? Do you remember? And then when we have that 2 added, that 2 becomes the 100th place. We remember this because of our decimals, right? Right? The 3 is in the 100th place. Okay? But it works both ways on the decimal part. All right? So if I have a number that's 132, that 2, okay, is in what place really, though? Think about it. Because on the decimal point, the 2 would be in the 100th place, but really it's the 1 that's in the 100th place. Okay? So if we take this number and split it up, did I say 32 or 23? I don't really care. Okay. All right. Here is our 1th place. Here is our 10th place. Here is our 100th place. I said 100, funny, but you get the idea. All right. Think about that. And all we have to do to know what place we are is just add the zeros and times it by its base. Right? Okay, we're multiplying by 10 every time. 10 times 10 is 100, times 10 is 1,000, times 10 is 10,000. Does that make sense? This is our number system. We just don't look at it like this from this perspective. Okay, because we've been taught by memory how to look at numbers. Okay, and the problem with that is, with anything, if you don't look at numbers from a perspective, okay, or from why we do the things we do, is just listen to the elementary teacher back in the day. Okay, they taught it that way for us for a reason. All right, we're kids. Okay, all right. At the same time, we don't go back and re-look at math from that perspective unless we become a mathematician. All right, seriously. Okay, and the relations of these numbers, they mean something. Now, let's look at this. This is where my horrible drawing goes into play. Here we go. I kind of like this tool. It's pretty nice. All right, so now you're driving along, and now you have a choice to go this way or this way. Okay? Now, one of the things that I never got to do, which I wish I did, and I almost did it, but I made a choice to go into Cisco instead. And that was to really learn electronics. I mean, to really understand voltage. Okay, you can be an electrician all day you want, but you don't really understand voltage until you become an electrician. I mean, an electronics guy, right? And that's something I wanted to do so bad, and I had to put it to the side. All right, I even got circuit boards, like those little kits for you. I had to show you one day. The little kits for you to test, and it's funny when I go through it and I do the sample for putting all the resistors where they need to go and stuff like that, and turn it on, it never works. Never. If I go back and follow the exact placements where the resistors go on the diagram, which logically looks exactly the same way to me as it does in the diagram, it works perfectly. But when I do it on my own, what does that tell you? I have no real understanding what I'm doing yet. Okay? So as we're taking this road, we don't understand where we're going, and we don't have to. Okay? The bottom line is what we have is a choice at this fork in the road. Okay? All right? Now, here's the thing. Okay? And let's do this here. It's painful, I know, but still. Okay. A computer speaks in machine language, guys. Machine language is just ones and zeros. Okay? All right? And before you start thinking this is irrelevant to networking, you're wrong. Okay? Completely wrong. All right? And it's going to start making understanding when we talk about the IP addresses in more depth. Now, without this knowledge here, okay, you might as well forget understanding IP addressing, because how are you ever going to do anything if you can't even create an IP address scheme? You're not. Okay, so now, regardless how we create a one and zeros, okay, it's a choice. So a computer uses circuits, resistors, capacitors, and transistors. And transistors are nothing but forks in the road. All right? That's my analogy. Okay? Now, the computer still has a choice to make. Those choices are most basically done by input that you put in the computer, whether it's a keyboard stroke, a mouse click, or programming, which is done in the background and it's already done. However, you made the choice in the program to go in the direction you want to go. Okay? You don't have to understand machine language all the way down there unless you're doing low-level programming, I believe, and I don't even know how to do that, so that could be a false statement. The bottom line is this. I can use electrical signal, okay, to make that choice. Now, if I have 3 volts on the circuit, it's a 0. If I have 3.5 volts, it's a 1. Those numbers aren't accurate. All right, but you get the idea. That's how I make a choice. Okay, so I'm saying, hey, I need to go in this direction. I need to make a right. All right, that's a 1. That means I have to send 3.5 volts down to that transistor. It'll close the 0 circuit, okay, because that one's going up here. It's going to close it, okay, or not make it accessible, whatever it is, because technically they're both closed if you want to look at it from that perspective, but that's not normally the case. 0 could be open by default, okay? All right, and that's the path it always takes until that voltage hits 3.5. Closes path 0, path 1 opens up, okay? There are trillions of transistors in a processor, okay? Microtransistors, all right? I believe they are, never mind, forget that. So nonetheless, okay, those decisions are made. Now, check this out. You decided to take the path 1. Guess what? Okay, your path does not stop there. Okay, because now, as you're going down this path, you're going to have another choice. All right, 0 is always going to be up, 1's always going to be the right. And now this is 0. Now, this choice, okay, for you to go up this way, because 1's always open, so we're going to close 1 and open up. Well, no, we'll just say 0 is always open. Okay, all right. Nothing changes, so we're going to keep it as a 0. Okay? Now, check this out. We're using a laser for this because it's on a laser disc. Okay? Now, if the laser can go through the actual CD, okay, it is a 1. If it bounces back and doesn't go through the CD, it's a 0. No light is 0. Light that comes through is a 1. Okay, so we have no light coming through. So we're taking this path up here. Woo! Okay, then we have another choice. Okay, and we're going to go this way. We're going to take the 1. All right, now this 1, I don't know if I said that correctly, but I'm sorry if I'm confusing you. You get the idea. It doesn't matter. It's choice. one or the other. That's it. You got two choices every time. However, your two choices have turned into thousands of choices. Does that make sense? And by the time we're done, it's going to be more than just a choice. It's going to be a tree of paths. Literally, like drawing a tree branch. Okay, with a bunch of branches coming off. All right? So now, this one is being used by a magnetic field. Okay? All right? This will determine whether it's a 1 and 0 and which path I'm going to go. Okay? Next thing you know, we're going to be using on the next path because we're going to go up in this direction, not this one. Okay? We're going to go up. All right? That is done by light. If a light shines through the actual if the light hits, it's a 1. If the light doesn't hit in that time interval, it's a 0. Okay? Does that make sense? All right? This is how transistors are doing. So in binary, in machine language, okay, and I'm gonna stop the video because I have to, do something real quick, but I'll be back. In our world, 1s and 0s rule the machine language because that's the only language the machine speaks. Okay, wow, just like that. I'm back. You didn't even know it. You're not going to know it either because it's just going to cut over to the next scene. Okay, so with all that information being said, okay, we're going to take a trip in time, back in time. For those who are around my age, right, and grew up on the Nintendo and Sega Genesis world, okay, we're going to talk about that in a second. Now, that means if we could only have either a 1 or 0, we have a 2-based system, not a 10. 2. And if we take our trusty calculator, okay, and we take 2, okay, and go to the 0 power, that equals 1. If we take 2 and go to the first power, that's 2. We take 2 and go to the second power, that's 4. We take 2 and go to the third power, that's 8. Okay? Now remember, in our 10-base system, we would just add a 0 because we're doing it times the base, right? Same thing, guys. 1 times 2 is 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. 64, 128, 256. And you're going to start remembering these because all you're doing is doubling them up. And you're always starting with 1 when we come into binary. 1, 2, 4, 8, 16, 32, 64, 128, 256, 512, 1028, 2004, 48, 4096. You see what I'm saying? Okay? 8,192, I believe. All right, these are going to be embedded into your memory. Okay? Make sure they are. You better practice. Okay? All right. If you're going for the exam, I haven't taken a CCNA exam since 2009. I have no idea. All I know is I was in an uproar when they changed the CCNA because I was really, really disappointed in the direction that they went. I'll keep my opinions to myself at this moment. No, screw that. All right. The bottom line is I felt like they were creating weaker CCNAs when they were weak in the first place. Okay. All right, you might have a CCNA and you might feel proud of yourself, okay, but we don't take CCNA seriously for a reason, okay, all right, and that reason really is, first of all, most of you guys are not even really taking it seriously. You're cheating, okay, and that's, I have no respect for it, okay, and if I was mentoring you and I start asking questions, I'm going to tell whether you're taking it seriously or not, and the moment I have a small expectation that I felt that you did not study, okay, or cheat on an exam, dude, I'm done talking to you. And don't think I haven't done it before, because I have. That's why you have no respect for it, all right? The hard work, okay, let's be honest, okay? You can challenge me all day, okay, and I can tell you on every subject. I don't know what the hell you're talking about because I don't know. I've never touched it before, and you can call me an idiot. But the bottom line is, I've already proved on YouTube and in this industry, okay, the knowledge that I have obtained, okay, and you can't fake that. All right, nobody sits there and makes 2,000 videos, okay, on technology and has so much to speak upon when they cheated the whole way through. Right? Okay. So when I ask you certain questions, and I'm mentoring a couple of people, and I got one person that's always answering the question in a way and hey, it could be 90% wrong, but the way he answers it, okay, means that he may be talking about the wrong technology to solve the solution, but his knowledge of the technology was deep enough to say, well, shit, at least you know that technology, but that's not what I was talking about. Where the other guy will give me an answer like, I don't know, a cat, dogs and cats sleep together, which is completely irrelevant to the technology that I was talking about in the first place, right? So trust me, we don't take CCNA seriously for that reason, meaning that you have a CCNA, you're coming aboard, okay, guys, you're spending your whole time in an interview proving that you know what you're doing, okay? CCNP, I'm telling you, once you get that, all right, and I mean really take it seriously, if you're getting a CCNP in a couple of months, guys, all right, yeah, whatever. All right, so bottom line is, once you get to that route, all right, and your interview experience changes. You still got to prove yourself, don't get me wrong. And you got to prove yourself on a higher level too, boy. Those questions, boy, God, man. Jeez, I don't miss those interviews, man. They're powerful. They do make you better, though. They make you a better person, make you a better interviewer, and it's necessary, okay? But there's a difference between interviewing a CCNA and a CCNP and a CCIE. Huge difference. Okay, so nonetheless, back to base. Okay, so now, only thing you gotta remember, guys, is this number. Start with 1 and double it, right? 1 times, here we go. Let's do it this way. 1 times 2, 1, sorry. 2. Okay, so we have to do it like this, really. It was just kind of weird. Because you got to remember that 1. That's usually what screws you up, okay? So 1 times 1, then 2. See, I told you. I got to be careful. All right, 2 times 1, then 2 times 2, then 2. It can't be 2 times 3, is it? No, because 2 times 3 is 6. Do you see? That's why the power of is the best way to do this. See? I almost confused the shit out of you. Just that easy. Just that easy. Okay? So forget that. Double them up. 1, 2, 4, 8, 6. Okay? But you have to remember the 1. The 1 will always screw you up, man. I don't know why. It just always did. And I will always be off my numbers because I'll always start with the 2 and not the 1. Okay? Now, the interesting thing about hexadecimal, okay? Hexadecimal is a system where, remember I told you, every letter is a value from 1 to 15. How is that possible? Let's take a look, okay? We're going to copy this. Okay, now these are 4 places, right? 1, 2, 3, 4. Okay, and we're going to do the math here. Oops. 1. Oops. 2, 4, 8. Now, the interesting thing with binary is this, okay? Remember, 1 means something, 0 means something. In our math of binary, a 0 value under that value, which means these are our placements, okay? These are our values of those placements, okay? And then we get to either turn that number on or turn that number off, okay? And if I say 0, 0, 0, that means bit 3, bit 2, bit 1 are off, okay? But bit 1 is on. Now notice what I talked about the router, okay? That the router will always have a 0 interface. Remember I said that? Okay, so our first interface will be 0, 0, or just 0, okay? Here's the same way, okay? This takes practice. It's confusing. It makes sense, but I'm explaining it to you. At the moment, I'm explaining it to you, all right? You're going to forget tomorrow. You're going to come back to the video and say, oh, that's right, and then you have to go back and listen to all the goddamn stories I was telling and all that annoying stuff. So learn how to skip through the videos or write down the timestamps. Come on, guys, use your brain. All right, that's why video training is amazing. Every day I would come home, I could watch the same video. I'll go right to my timestamp because I had it written on my whiteboard. And if you don't think I have a whiteboard, there it is over there. All right, now, okay, that means, okay, that means that 0001 equals what? Huh. Let's go to the calculator. Let's find out. We're going to go to programming. We're going to click on binary. And we're going to say 0, 0. But I don't know if that is on. Okay. 0, 0. Okay. What's going on here? My calculator apparently is not working, or I'm doing something wrong. It's been a while since I've used one of these calculators, binary. Huh, I guess I can't put them in there. Okay, so let's go back and let's do a 1 on a decimal and let's find out what it is in binary. Okay. And you're confused because like, well, I don't understand. Why does it equal 1? Because you're looking up here, that's why. The value of 0, 2 to the 0 power is 1. So all we're doing, guys, is adding up the ones that are value of a 1 of the binary code. What happens if I turn all these on 1? Now we add them up, okay? Now watch. Now I can use my number pad. I always thought I could put binary numbers in there. It's just weird. I don't know why. I guess I got to go online to do that. But nonetheless, 8 plus 4 plus 2 plus 1. And what are our numberings for hexadecimal? 1, 2, 3. Oh my God. 1, 2, 3, 4, 5, 6. Actually, I don't need to do that. Let's copy. Let's right click here. Probably better if I actually just continued on. Table insert left. Okay, so now we're going to insert right. $11, $12, $13, $14, $15. Okay, what are our values in our 4 bits? 1, 2, 3, 4 bits. What are our values? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. A, B, I don't know why they capital. Oh, I don't know why. C, D, E, F. Okay? That's why, guys, in order for us to have values 10 through 15 with a 4-bit system, because all those numbers equal added up is 15. we got to find a way to identify that our value is on a 10, 11, 12, 13, 14, 15. So we use letters. That means every bit. Sorry, my coffee's getting in the way. Every bit of our MAC address, every digit is 4 bits in length. Okay? So how do we write 0 for this first 0 digit? That's what it is. 0, 0, 0, 0. So if I wrote out the first 4 digits, okay? All right? Let's go ahead and copy them here. Are you serious? Okay. I don't know why I didn't come up with paste. Okay. Let's go ahead. All right. The first 4. Oops. Don't want to do that. We are going to say, actually, I wish I could do that. There we go. Now, what's E? E is what? 13. So let's do our placements here. In order to get 13, you know what? I'm going to teach you how to do it, okay? So we got the value of 13. Okay? Does 8 go into 13? Yes, it does. 1. Okay? Minus 8. Okay? What does that equal? Oops. That equals 8, 9, 10, 11, 12, 13, 5. Yeah, I had to count them with my fingers. Okay, now does 4 go into 5? No. Okay, does 2 go into 5? Yes. That leaves us with what? Oh, I'm sorry, 4 does go into 5. All right, no one ever mistake me as someone who knew how to do math. Okay, so minus 4, okay? And that leaves me with 1, okay? Now, if I have a number that's bigger, which is what we end up having, right? I had 3 left over if I minus the 2, thinking that 4 did not go into 5, okay? And I had 3 left, but I don't have 3 bits left to actually subtract. That means I did my math wrong. Okay? So, does that make sense? So I'm kind of glad that actually happened. So now we got 1 bit. 2 does not go into 1. So that's 0. Okay, and then 1 goes into 1. And that leaves us with 0. All right, so when we subtract the 1 here, we'll have 0, no more bits left. Okay, now, let's check our calculator. Because remember, we're looking for the value of E, and E equals 14. So now let's check our calculator. 14, and let's go to binary. 14 equals 1110. Let's look at it again. 1110. Okay, we did a math wrong, so let's try it again. 14. Oh, by the way, I'm not kidding. Okay, and this is why I'm doing this. I mean, it's not by design, but luckily it's happening. Things always go wrong in my videos. Okay, and that's why. And then we go back and we correct them. All right. If I'm doing this now at the level that I'm at, what do you think you're going to do at the level of you understanding and trying to learn this? Okay. Remember what I told you, must go through the path of hell to get to heaven. You must fail to succeed. Okay. And you're going to fail a lot. Failure should never be depressing. It should be rewarded because you took the time to actually learn it. Every failure is a learn. All right. Okay. If I can get your fear to transfer over into a positive, my job is done. Okay, so, you know what I think we did? Let's go back. Let's Control Z here. I did 13. That's why. That's why I messed up. Okay, so 14 minus 8 equals 6. Okay, so 4, and this will be 2. So the calculator is correct. Never. I'm going to tell you 2 things that I've learned in life. 1, with binary, okay? While you're practicing binary, always do it on paper. Yes, always do it written out. It's the only way for you to learn. All right? Running a business, never do your checkbook with math in your head. Always use a calculator. Always. One number gives you more money than you think you are, and you're bouncing before you know it. Number 2, when you're engineering, never rely on your binary math, okay? Because every time, it's going to come bite you in the butt. Use a calculator, just like I showed you, okay? I don't care if you go online and do whatever you need to do with subnetting, okay? Learn it from this level to understand it in depth. However, never in an engineering position do your own math. I am fair warning you from experience. Okay, all right, so you literally watched me fail and how I handled that failure. Okay, all right, we're human, guys. This is what we do. All right, 9 times out of 10, and this is from my 1994 days, technically that whole era. It's from my PC days. 9 times out of 10, okay, you're the mistake. It's not the PC. It's not the software. 9 times out of 10, it's you, okay? And anybody who is a help desk or IT knows the ID10T error. I had to think about it for a second. All right, you're on the phone. They're telling you what the problem is. Oh, sir, I know what that is. That's an ID10T error. Okay, now let's actually write that out. ID10T error. Okay, change that 1 to an I. Yeah, it's like that. Because that's what we are. Our brains are perception, not reality. And until you're able to understand that, and sometimes you got to have a stroke in order to understand what you really are and not in control of. because you're not in control of anything that your body does. Just because you raise your hand because you want to don't mean crap. It's not you doing it. It's your brain doing it. And your brain is deciding to actually comply to your request. That's it, man. Once your brain decides that, it doesn't know how to do that, you're done. Matter of fact, it might not decide it wants to do it. You're done. You're not in control, man. You just think you are. Okay? And you can argue with me all you want by choices and free will and all that stuff. Guys, you are not in control of squat. And unfortunately, like I said, it takes a stroke for you to realize that. And if that's what it takes, hey, bring on a stroke, right? All right? That's a hard thing to say, okay? And it's not, strokes are not a joke. And I know from experience that they're not jokes. But the bottom line is, I'm serious with that. I'm not kidding. Okay, all jokes aside. All right, in order for you to understand what you're not in control of, you must experience, you must walk through hell to get to heaven. Is that starting to click now? Is that starting to make sense? Okay, so now, remember back in the day, okay, when we had, actually, let's go look it up. Let's look it up. Okay, let's go to Google. All right, and okay, how about Sega? What is it called? Oh, menu popped up. Eight bits, third generation home system. God, that thing looks gorgeous, man. I remember having that, man. I remember playing Space Harrier on that thing, man. I used to love it. Okay, so check this out. 8 bits. What does that mean? You know what? We're going to write it out. Okay? All right? It's already written out, actually. All right? 256. Does that number ring a bell? 256 colors? Yeah. Hell yeah, boy. I remember the first time I made that connection, I was like, oh my God. The whole time I've been, we used to talk about it all the time. Oh man, 256 colors, man. But we never knew what 8-bit system meant. All we knew was, an 8-bit sound. We had no idea what that meant. Okay? We just repeated what we were reading in the diagrams. Okay? Not the diagrams, in the magazines. All right, you talked about this. Oh, this is an 8-bit system, right? And you glorified it. So we, as nerds, with our nerd friends, glorified it as well. Oh my God, dude, you have no idea, man. We got an 8-bit system, man. These games are going to be awesome, right? Especially from Atari days. I'm curious, matter of fact, after playing table tennis, I used to love, and Frogger on my damn Atari. How many bits in Atari system? There it is. I had no idea that was an 8-bit system. Okay, and it's funny because I would think it would be 4 because those games were, hell, you'd be lucky if you can get them in color. Seriously. And Frogger, I used to play religiously. Matter of fact, I would like to get that game just to play, or even download an emulator, which I'm sure I have. I'm sure I have it, and go back and play Frogger. But it's not the same with the joystick. You see what I'm saying? Okay? But this takes you back in the day, especially people my age who grew up on Atari and grew up on Sega Master System and Nintendo, Super Nintendo and Sega Genesis. Okay, those are games. Okay, and then eventually my first PC game, which is how I got into PCs. The only reason why I got into PC was gaming. Okay, was Stone Keep, and still today, guys, they have to remaster that game at some point. Stone Keep is still a good game, but god damn, it is so horrible to watch the graphics. It is so pixelated. It's you just can't deal with it. All right, it's that bad. But nonetheless, okay. So back to topic. Now we learned what our 256 colors meant. Okay. All right. What these are, these bit values are possibilities. Okay. That means, okay, in an IP address like this, we got 4 numbers. Each number, my friend, has 8-bit possibilities. That means something. That means we have a maximum number we can get to. And I'm curious on what that is. Right? Now, well, 8 bits gives you 256 values. The possible number that you could put in an IP address is 0 to 255. Now, you're like, well, that's not 256 values, it's 255. Is it? Because if we start with the 0, 0 is 1. 1 is 2. 2 is 3. Okay, and now you're seeing that means 255 must be 256 since we're already 1 number ahead, each number already. You're forgetting the 0. Okay? All right? That means I can have an IP address of 192.0.0.1. Okay? Each place has 256 possibilities because it's 8 bits possible. You take 4 bits together, okay? If it's a 4-bit possibility, it's called a nimble, okay? If you have 8 bits, it's called a octet. I think 4 bits are a nimble. I can't remember, but still. All right, look it up. Yeah, actually, let's do it right now. Four bits, okay? That's always right. Now, 8 bits are an octet. That means we have 4 octets. 8 times 4 is what? Let's go to our trust. Where's my calculator? Why do I keep closing it? 8 times 4. Oh, well, that's interesting. That means we have a 32-bit addressing scheme with IP version 4, okay? Because we have 8 bits in each number, okay? And the maximum number we can go to is 255. The highest address we can have is 255.255.255.255, okay? All right? Now, that's pretty cool. Now you understand why our IP addresses are labeled the way they are. All right? And it's going to get even better. All right? That's why you've never seen an IP address of 255. And you know what's funny? Let's see if I can find this video here. Come on, come on, come on, come on, come on, come on, come on. You know what? I'm going to find this. All right, hang on. Let me stop this and I'll come right back. Okay, right when I stopped the video, I found it. Here we go. All right, it's in horrible, horrible resolution. And the max is 240p, so.
What do we got? Brute force logging. The interesting thing is, even though he's coming in through Hong Kong, Korea, and Malaysia, he's trying sequential account numbers. He's hacking all over the board.
Now, what that person is looking at right now is Wireshark, okay? Or a program similar to it. It looks like Wireshark to me. Someone's just actually... Okay, now, he's literally typing out parentheses router config, okay, which is what you'll see in the prompt itself. This is not something you type in. Okay, IP access group.
That slowed me down.
All right, now let's go back and take a look at the IP address. All right, so he is an IP access list. All right, he did that correctly. Access list 1, deny, except he wrote out router config in parentheses with a pound. You don't write that out. That's what your prompt is. Access list 1, deny 172.16.4.0. Okay, this is embedded into my memory because it's the first time. Okay, I've actually watched this movie actually after learning this stuff. And when I saw it, I was like, "That's cool as hell." He even goes into Ethernet 0 and creates an actual access list and actually applies an access list. All right, pretty cool, huh? All right, but
that slowed me down. I'd be resistant to false positives too. Yep. Thanks.
All right, and it's funny because the words that they're using, brute force attack, okay, false positives, these are the things you learn when you go into security. But it didn't show what I wanted it to show, okay? It must have been another movie then. And they were actually having IP addresses that were higher than 255 in each octet. I think the first octet was like 360 something, right? Okay, and that's no way that's an IP address. It's just you don't catch these things, okay, and it makes you feel wonderful when you catch them because you're trained. It makes a huge difference, guys. All right, and I thought that video had it, and it didn't. All right, I thought it was hilarious that he actually typed out router in parentheses config. They didn't have to do that. They could have actually had it, but again. Obviously, they didn't have a real router, okay, and they were using probably, I don't know, they're probably using a simulator. Who the hell knows? I don't know. But nonetheless, that's the end of that video. And always remember, be strong, be determined, be Cisco.